Okay, today we're going to talk about factoring the greatest common factor. You've already done this. We're just going to practice some more today and get really good at it so that with our next lesson we can factor out a greatest common factor that has more than one term. So let's look first at the number 8. If I wanted to find two factors of 8 that I would multiply together to get 8, I could choose 1 times 8 or I could choose 2 times 4. Okay, if I want to find factors of 8x, I might choose 1 times 8 times x, or I might choose 2 times 4 times x. Alright, anytime we have an expression written in factored form, what we are showing, factored form, we are showing that it is written as a product of its factors. Factoring a polynomial reverses the multiplication process. So basically, it's division. Alright, so let's look at our turn. We're going to factor these two polynomials. They've given us the factor they want us to take out. So we're going to take 2x squared out of each term that's in the numerator. I'm going to rewrite this first one so that I have each term separately divided by that denominator. So when I rewrite it, I have the first term, 8x to the 4th, divided by 2x squared, minus the second term, 2x squared, divided by 2x squared. When I do that, I can see that 8 divided by 2 is 4, and x to the 4th divided by x squared is x squared. And then I'm going to subtract the next term after I simplify it. But look, 2x squared divided by 2x squared, that's 1. Anything divided by itself is 1. So my answer here is 4x squared minus 1. Okay, looking at this next problem, I'm going to zoom in a little bit. I'm going to divide each term by 3x to the 5th y. I have 1, 2, 3 terms. Okay, so I'm not going to rewrite all of that. You can on your paper if you'd like. 12 divided by 3 is 4. X to the 5th divided by x to the 5th is just 1. Anything divided by itself is 1. I don't need to write that I've got multiplied by 1 here. I don't have to write the 1. Y divided by 1 is also 1. I don't have to multiply by 1 because we know it'll still be 4. So I'm done with my first term. Now I need to divide my second term. 3x to the 10th y to the 3rd divided by 3x to the 5th y. I can see that 3 divided by 3 is 1. X to the 10th by x to the 5th is x to the 5th. Remember, in this case, we subtract the exponents. And y cubed over y is just going to be y squared. I did not need to write that one coefficient, but it's not going to hurt anything. Slide my paper over. So my last term, 21x to the 15th y to the 4th, divided by 3x to the 5th y. I'm going to say 21 divided by 3 is 7. X to the 15th divided by x to the 5th is x to the 10th. And y to the 4th divided by y is y cubed. So this polynomial, 4 minus x to the 5th y squared plus 7x to the 10th y cubed is the answer here. Alright, you can do the two your turn problems by yourself. You can pause the video. I'm going to slide on down here. Sometimes we need to figure out how to factor a whole polynomial on our own. We are not given the denominator. So when we do that, we're going to divide by the greatest common factor. Okay, so steps for factoring out the greatest common factor. You're going to find the greatest common factor of all of the terms to figure out what it is first. Then we will divide that greatest common factor, that factor, from each term. And finally, we're going to write our answer as the product, which means we can multiply it together, right? The product of the GCF and the quotient. It's kind of like using reverse distributive property. Okay, you can always check to make sure that you have factored out the correct thing by multiplying. Always check by multiplying. All right, flip your paper over. So I'm just going to do a couple of the your turn problems. I'm going to take a look here at problem number 4. I'm going to pull out the greatest common factor I can find for each of these 3 terms. Okay, so I can see 16xy squared minus 24y squared z plus 40y squared. If I look at the numbers 16 and 24 and 40 and think about what is the biggest number that can go into each of those, I'm going to choose 8 because 8 goes into 16, 8 goes into 24, and 8 goes into 40. I'm going to pull out an 8. Now, I have an x in my first term, but I don't have an x in my second term or my third term, so I can't pull an x out of everything. I have y squared in my first term, y squared in my second term, y squared in my third term. Since I have y squared in everything, I'm going to go ahead and pull that out too. Y squared. Okay, now I'm going to see what's left. 8 goes into 16 2 times. Y squared goes into xy squared just once, and it leaves me with x, right? Okay, my next term, I'm going to subtract. 24 divided by 8 is 3. Y squared divided by y squared is just 1. And z doesn't have anything that it's going to be divided by, so I get to keep the z. My last term, 40y squared, I have 40 divided by 8 is 5, and y squared divided by y squared is just 1. I don't have to write that because I'm multiplying. So my answer should be 8y squared times this polynomial, 2x minus 3z plus 5. To check it, I would distribute that 8y squared back through and make sure that I have my initial problem. Okay, I'm going to look at problem number 5 here on this video. 10wz plus 2w squared z. I can take out 2w from each of those terms. 2w. 2w goes into 10wz 5z times, right? 2 goes into 10 5 times, w goes into w 1 time, and nothing is dividing into that z, so I just keep z the same. For the next term, 2 divided by 2 is 1. I don't have to write 1 because I'm multiplying. W squared divided by w is w, and z is not being divided by any other z's, so I'm going to keep it the same. So that would be the answer to problem number 5, rather. You can fill out your notes the rest of the way, following along with me, or you can try to do the rest of the our turn problems on your own and then check back in to see if you got the correct answers. So I'm going to take a look at number 1 now. 25a squared plus 15a. I know that I can take 5a out of each of those. I can take a squared out of the first term, but I can't take a squared out of the second term. That's why I'm just doing just a to the first power. So if I take 5a out of here, my answers inside are 5a plus 3. That's because 5a goes into 25a squared 5a times. 5a goes into 15a 3 times. Let's look at number 2. I'll say it a slightly different way. This time when I look at every piece of information in each term, I see that I can take out 6x squared. So if I back up and think 6 goes into 18 3 times, x squared goes into x squared 1 time. I don't actually have to write anything else. 6 goes into 12 2 times. X squared goes into x cubed 1 single time, but it leaves me with an x as a remainder. Okay, so this would be my answer. We like to write our answers in a different order, though. We would rather see this as 6x squared times negative 2x plus 3. So here, I might argue that I'd like to take out a negative 1 so that my first coefficient is positive. If I choose to do that, now that I've rearranged my terms in there, I'm going to pull a negative 1 out of each one of these terms. So that means that I have a negative 1 times everything outside of my parentheses. I'm going to divide negative 2x by negative 1, so now
Wilson,
it's 2x.
stall to the office for dismissal, please. Wilson, stall to the office.
Well, that's just put out there forever, isn't it, that announcement? Sorry. So I'm dividing my negative 2x by negative 1, and I stuck that outside of my parentheses, and so I'm dividing 3 by negative 1, so that's going to give me negative 3. Both of these pieces of information are exactly the same mathematically, but we like to have the first term inside parentheses be positive. That just makes life easier for us. Looking at number 3, I'm going to divide each one of these by 7 because I can see 7 goes into each of the constants. I have b to the first power in each term. So I'm going to take 7b out. Okay, 28 divided by 7 is 4. B squared divided by b is b. 21 divided by 7 is 3. B divided by b is just 1. 3 times 1 is 3, so I don't need to write that. 35 divided by 7 is 5. B squared divided by b is b. And then c squared is not being divided by any c's at all, so we keep it c squared. Okay, and finally here, once I have my polynomial in parentheses, I'm going to want that first coefficient to be positive. So I'm going to go ahead and divide by just negative 1. I don't have any other numbers that I can divide into each of these coefficients, just negative 1. So I'm going to say negative 1 outside, negative 1, and then I have m to the 4th, m cubed, and m squared. I'm going to pull m squared out of everything, so negative 1 m squared. Okay, negative 1 goes into negative 6 exactly 6 times. M squared goes into m to the 4th, m squared times. Negative 1 goes into 5, negative 5 times. M cubed divided by m squared is just m. Negative invisible 1 there, divided by negative 1 is going to be positive 1. So I'm left with a positive inside, and m squared divided by m squared is 1. This is 1 because m squared divided by m squared is 1. Negative 1 divided by negative 1 is 1. It's not 0, it's 1. So that would be my answer there. I can check my work by multiplying that back through with distribution. Negative 1m squared times 6m squared is going to be negative 6m to the 4th. Negative 1m squared times negative 5 is going to be positive 5m to the 3rd. Negative 1m squared times 1 is negative 1m squared, or just negative m squared. This should be exactly the same as my initial problem. And so let's check. It is exactly the same. So we got it right. Great.